Okay, continuing on in ALEKS College Algebra, we will be in the exponential and logarithmic functions, and we will be expanding a logarithmic expression problem type 1. So let's see what they have given us here. Alright, notice here we want to use the properties of logarithms to expand this this expression. So let's get this problem written down and once again consult with our notes. Okay, and here's the problem that we have. Notice too that we are going to need to keep at hand here our notes about logarithms that we developed earlier, so you can have this sheet of notes at hand. This will help us. So let's look at the problem and see what we have. First of all, notice that we have the base 10 because there is no base specified, so these are base 10 logs, and the first thing that we're doing is that we're dealing with a quotient. We're dividing. So if you remember the rules of exponents, that when you divide you subtract the exponents. So what we're going to do then is to write a step. We're going to have the log of z to the 7th, and from that we are going to subtract the log of x, because what we have done there is we have simply applied this second rule, that when you have the log of a quotient, it's the log of the numerator minus the log of the denominator. Or again, whenever you divide, you subtract exponents, you subtract logarithms. Now notice here though, we have a logarithm of z to the 7th, and so we have the logarithm of a number raised to a power, which also is a rule. In fact, that's the third rule. When you have this logarithm to the base a of some number raised to a power, what happens is that that power comes out in front and is multiplied by the logarithm. So applying that to this case, notice what happens is that this 7 immediately is pulled down front, so we will have 7 multiplied by the log of z minus the log of x. And so that is how we write the expression that ALEKS wants. Let's go back over here and put that in, and we will have 7. Notice this button here gives us space to do that. So we will have 7 times the log of z, and then of course we're going to want to subtract the log of x. And so let's check it. Let's do another one of those. And notice that we've even got a more complicated mess. Let's get this one copied down and we'll work on it too. And here is our new problem. Now first of all, notice here that we are taking the logarithm of this quotient. So the divide fraction bar in here means quotient. We're dividing, and when you divide, you remember you subtract the exponent. So what we're going to do is subtract those logarithms. Let's write a step. This is going to be the log of x minus, and then we will have the log of z to the 5/7. So there's our first step. Once again, what we're basically doing there is applying the second rule, the quotient rule, which says that you subtract the logarithms. Now, as you may guess here from the last one, we're also going to apply the third rule, that when you have the logarithm of a number raised to a power, what happens is that that power comes down front, so that we multiply the logarithms. This again is nothing more than the rule of exponents. When you raise a power to a power, you multiply. So you grab this 5/7, you pull that down front, we write our answer, log of x minus 5/7 log of z. So we get this answer. Let's go back and put that in ALEKS and see if that makes him happy. And so we will have the log of x minus the fraction 5/7, then times the log of z. Let's check that. And again, ALEKS is happy. This is expanding a logarithmic expression, problem type 1.